Assalamualaikum. Today we will be exploring further into our topic, solution of triangles. Our group will be focusing on questions regarding 3D objects involving an angle between a line and a plane. Before we jump into the questions, we will begin by explaining our basic concept, then onto the application of trigonometry knowledge, and only then shall we provide the example questions. Alright, in this chapter, you need to understand these basic concepts for this topic. For example, here we've got plane A, B, C, and D, and a standing line EF. So actually, we consider that plane A, B, C, D is a paper and line EF is pencil. Now, imagine directly, above the pencil and the piece of paper, there is a light shining towards the object. With this, a shadow line will be formed, which we call as an orthogonal projection. Then, since we have the standing line and the orthogonal projection, we can then connect them with a normal line, which is a straight vertical line from the plane that forms a 90-degree angle or a right-angled triangle. Therefore, if you are asked to find the angle between the plane and the line, you must first detect these two components first. So this is angle of between the plane and line.
Application of trigonometry knowledge. Now that we've understood the basic concept, we can then continue with revising back on previous knowledge, which we will have to use in order to help us solve questions regarding this topic. Okay. With our understanding of the concept, we now have achieved a right-angled triangle. Hence, in order to calculate an angle, we have to apply trigonometric ratios, which we know as SOT. These are the formulas.
Okay, now we will head on to solving questions within this topic. It is recommended for you to pause the video and try solving yourself first using what we have just learned, and then continue to see the correct answers. In total, there are 3 questions, so let's go. Given that AM is 15 cm and M is the midpoint of EH, find the value of angle between the line AM and the plane ADEF. First, we have to find the plane and line. Given in the information, the plane is ADEF, so in order to visualize this better, we can redraw this to look like our first diagram, a plane and a standing line. Based on the diagram, we can see line AM, where the bottom of the line starts at point plane A and rises to M, where M is the midpoint of EH. Therefore, M is directly above point plane E. So it looks like this. Then, we must detect the orthogonal projection. Since the plane is at the side, the light that we imagine must also be from the side, which can be seen as line EA. Then detect the normal line, which can be seen as line EM. With this, the right-angled triangle is formed. The next step is to find the length of either side of our triangle. It is already given that line AM, the hypotenuse of our triangle, is 15 cm long. Then, based on the diagram, we are given that AB is 8 cm long, which is also the same length as EH. And M is the midpoint EH. Therefore, EM is half of EH. With this, we have gotten the length of the hypotenuse and the opposite side. Only now can we use the trigonometric ratio to calculate the value of the angle between the line and the plane. Given that V is the midpoint of line SP, calculate the angle between the line UV and the plane RSTU. Here we identify that the plane is RSTU and the line is UV. Once again, we'll visualize it to look like the first diagram and detect orthogonal projection, line SU and normal line VS. It is already given that the length of the opposite side, or line VS, is 8 cm long. Next, to obtain the length of another side, we must use Pythagoras' theorem, which will give us the value of the adjacent side of our triangle. With this, we can calculate the angle using trigonometric ratio, 10.
3. In the diagram on the right, PQR is an equilateral triangle with sides of 6 cm and lies on a horizontal plane. Point T is 4 cm vertically above the midpoint of PQ. Calculate A. the angle formed by TR and triangle PQR. So it is already given that the height of TPQ is 4 centimeters. Since T is vertically above the midpoint of PQ, it means the distance of the midpoint is half of 6 centimeters because all the sides are equal in length. We can see TR as a line, and R to midpoint PQ is its orthogonal projection, whilst midpoint PQ to T is the normal line. Clearly, it is a right-angled triangle. So we can use the trigonometric ratio to find the value of angle between line TR and plane PQR. We can find the length of R to midpoint using Pythagoras theorem and insert it into the trigonometric ratio formula. Here we get 37.589 degrees. B. The area of plane TPR. In order to calculate the area of triangle TPR, we must know the lengths of its sides. We can find PT using Pythagoras theorem, and we get 5 centimeters. And we can apply Pythagoras theorem to get TR. In the formula to calculate the area of a triangle, we need to get an angle. Since we have the length of 3 sides, we will use the cosine rule. So, substitute all the values into the formula and express the angle A. Here, we get 72.5432 degrees. Final step, we substitute the values of length and angle into the triangle area formula.